Hey everyone, my name is Diane. I'm super excited to be joining you all. Today, we are going to be using our wonderful minds to think about a math expression. Before we jump in, let's talk about multiplication and some different terms I'll be using. What do you know about multiplication? Yes, repeated addition. Ooh, equal groups, that's another good one. The answer is called the product. It's like you read my mind. That was the next thing I was going to bring up. The product is what we call the answer to a multiplication equation. Today, as we are solving a multiplication equation, our big focus will be to think about how to decompose or take apart the numbers to make them easier to manage. Have you ever used decomposing numbers during other things with math? Oh, what's that? Oh, so you've decomposed numbers with subtraction on a number line? And you've decomposed numbers when we were at the grocery store guessing how much our favorite snacks would cost? Those are awesome examples. We're going to start off with a multiplication equation, and your job is to solve it however works best for you. Let's see if we think the same or if we think about it differently. If you think of more than one strategy, ask yourself, which one works better for solving this effectively and efficiently? Now, when I say effectively, what do you think of? Can you tell me? I think I heard someone say something about getting it right. That's true. If something is effective, it's doing what we want it to do. I like to think about being effective at throwing a football. If I throw it effectively, my team gets a touchdown and I get to do a dance. So, what about the part about efficiently? Oh, what did you say? I heard some of you say I heard the word efficient when people talk about putting gas in a car. That's another great example. Efficient is about doing something without using a lot of energy. So remember that touchdown that I just threw? If I'm efficient at it, I don't have to run all around before I throw, and I get to save more energy for dancing. So here's our first expression, 14 times 2. Think about this and think about solving it in whatever way you want. All right, so now is your time to share. Tell a friend or a trusted adult your strategy, and don't forget to think about if it is effective and efficient. That's a great idea. I love some of these strategies. I wrote some things down that I really wanted to share with you. One way I heard someone say was that they saw 14 times 2 as two groups of 14. Then they said that addition was something that they could do in their head, so 14 plus 14 equals 28. We'll use this answer to check our other strategies to make sure our products are consistent. So let's look at another strategy that someone thought of. I heard someone notice something about 14 that they made it easier for them to think about how to multiply the numbers. They said, I know that 14 is the same value as 7 plus 7. So I started there. So we can write 14 times 2 as 7 plus 7 times 2. Oh man, that really is helpful. That means that we are multiplying 7 times 2 twice because of the 2 7s here. Can you think of what number is the same value as 7 times 2? Did you say 14? That's right. 7 times 2 equals 14. So 14 plus another 14 is 28. Do you see anything similar with the two strategies we have talked about here? Yeah, it's true. They both came up with the same product. Oh, I heard something that I had thought about too. This last strategy was similar to the two groups of 14 that we talked about before. Isn't it interesting how we can all think about things in a different way, but there are still some similarities? One more strategy that I heard and wanted to share was that they used money to make sense of the expression. I thought that was a great example. So if I have a $10 bill and 4 $1 bills, that would be $14. So I can decompose 14 into a 10 and 4 ones. Then someone says, hey, you're going to get another $14. My first thought, awesome. Now, my bills are 2 10s and I have 2 sets of 4 ones. So we could write 2 times 10 plus 2 times 4. But how do these two parts match? I want you to ask yourself, what happened to the 14? Can you tell me? Oh, I think I heard it. It was split into a 10 and 4 ones. I would say that 14 was decomposed into a 10 and 4 ones. With this decomposing, we are able to do some mental math by multiplying the parts of 14 by 2. I really liked this strategy because 10 and 4 are friendly numbers for me to work with in my head. Maybe they are for you too. I know that 2 times 10 equals 20, and then I also know that 2 times 4 equals 8. With those two parts, I can add 20 plus 8 and get 28. If we look back at our original strategy, the products match. You remember what the product is, right? Exactly. It's the answer to a multiplication problem. Which strategy ended up being the best one for you? I know for me, decomposing 14 into 10 and 4 made the numbers really friendly to me. So let's try that strategy with another equation, 18 times 2. Try decomposing into numbers that will work really well for you. Let's meet up in just a second. All right, it's looking good. I think I have an idea. So now I'd like you to share your strategy with someone around you and share it with me too. Oh, that was a really good one. I heard a lot of people decomposing numbers. A strategy I heard that I wanted to share was how someone decomposed 18 into 10 plus 4 plus 4. They said it was easy for them to think about those values and keep track of them. So now we have 10 plus 4 plus 4 times 2. We can do 10 times 2 to equal 20, 4 times 2 to equal 8, and we have another one of those, so we have another 8. So to find our product, they did 20 plus 8 plus 8. So 28 plus 8 equals, oh, what's that? Oh, you added 8 plus 8 first? You got it, we'll scratch that. So 8 plus 8 equals 16, and then 16 plus 20 equals 36. I see what you mean. 28 plus 8 seemed a little more challenging to think about in my head than 16 plus 20. So our final product for this one is 36. That's a great job. Today, we looked at how to decompose a number and make problems more manageable. And we saw that breaking a number up can help us solve the problem using things we already know. I wonder if this strategy will work with other problems like this one. See y'all.